use CAD to support the core area of systems. We're going to begin with looking at TinkerCAD, and specifically the area of TinkerCAD called circuits. You'll notice the layout for TinkerCAD is similar to 3D designs, with a library of parts down the side, but we've also got a simulation tool up here which will come in handy. We can start by dropping in components and using them to assemble circuits in the first instance. There's a full library of parts that you can search in here if you need specific values, but you can also click on components to change their values. So I'm going to change this from 1 kilo ohm down to 380. It's really useful as well because when I hover over parts, it tells me what the part is. So when I construct my circuit, I know my positive needs to go to positive. Start my simulation, press my button and see it work. Most of these components are editable, so I can change the colour and see the effect that it has. There's a full library of instructions if your students need to learn how to use TinkerCAD circuits in the Learning Centre, which will take them through step by step how to edit components, wire components, all the way through to how to do more advanced simulations. In TinkerCAD circuits, you also have the functionality to breadboard your designs. And this is going to work in exactly the same way as real-life breadboarding. There are a library of components in here that also allow me to introduce other things to simulate. So for example, I can drop in a microbit and simulate my microbit on the screen, and I even have an area in here where I can code my microbit using a Scratch-based interface. And again, I can simulate my designs in there. I can also interact with my microbit by simulating temperature and light levels as well. Once I have my circuit and I've tested it, iterated it and recorded my processes, one of the really interesting things that I can do in TinkerCAD is use this button, which is Send To. And here I can send my design to Autodesk Fusion 360. This is going to be really useful when I want to start to create some PCBs. So I can see in here an example of the light sensor that I've breadboarded. I can put it together and export the PCB artwork to create my design. Lastly, you might be able to use CAD to consider the enclosures for your PCBs. In this case, I'm using a microbit. What I've done is to design a two-part case to 3D print or additive manufacture based on the design of the microbit. Of course, I'm able to go and take measurements from the microbit should I need to reverse engineer it.